Welcome to the session on trigonometric functions using sec, cosec and cot. The objectives for this session are to solve equations, simplify expressions and prove simple identities which involve secant, cosecant and cotangent. Let's remind ourselves of the graph of y equals sec x for x in the real numbers. This will look something like this. As you can see, there are no solutions for sec x equals k, for k between -1 and 1. Similarly, for the solutions for y equals cosec x. And here's its graph. There are no solutions for cosec x equals k, for k between -1 and 1. And now let's remind ourselves of the definitions of sec, cosec and cot. Sec equals 1 over cos, cosec equals 1 over sine, and cot equals 1 over tan. So since tan equals sine over cos, we have that cot equals cos over sine. Pause the video and have a go at this example. Press play when you're ready to view the solutions. So let's have a go at part A first. We are required to simplify cos theta, tan theta, cosec theta multiplied by each other. So let's solve this. Cos theta, of course, stays as it is. We can interchange tan theta with sine theta over cos theta, and cosec theta with 1 over sine theta. Now we can cancel. The cos thetas cancel, and the sine thetas cancel, leaving us with 1. And now for part B. We are required to simplify cos theta sine theta times cot theta plus tan theta. So let's solve this. We can leave cos theta sine theta as it is and replace cot theta by cos theta over sine theta. And tan theta can be replaced by sine theta over cos theta. Then we can expand the brackets to give this expression plus this expression. We can now tidy up using cancellation. So the sine thetas cancel here, and the cos thetas cancel here, leaving us with cos squared theta plus sine squared theta, which is of course identical to 1. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We are required to prove the expression shown on your screen. Let's solve this. We're going to begin by simplifying the left-hand side and trying to reduce it to the expression on the right-hand side, because that is clearly simpler. We have two fractions here that we're adding together. Let's put them over a common denominator. So here's our first fraction highlighted in red. If we want to put it over a common denominator, we need to multiply top and bottom by cos theta. Here. And similarly, here's our second fraction. In order to put this over the same denominator, we need to multiply top and bottom by 1 minus sine theta as shown. And so these two fractions can now be expressed over one common denominator. And tidying up gives us cos squared theta plus 1 minus sine theta all squared. So we have cos squared theta plus 1 minus 2 sine theta plus sine squared theta over the same denominator. Cos squared plus sine squared becomes 1, and 1 minus 2 sine theta is left as it is for the time being. And the denominator remains the same. The numerator can now be rewritten as 2 times 1 minus sine theta. And again, the denominator remains the same. The 1 minus sine thetas in the numerator and the denominator can now cancel, leaving us with 2 over cos theta. But of course, 1 over cos theta is equal to sec theta. So we have 2 sec theta, and we've proved part A. And now for part B. Using part A, we are required to show why the expression on the screen has no solutions. So let's solve this. From part A, we know that the left-hand side of this expression is identical to 2 sec theta. So we can rewrite this as 2 sec theta equals 0.2. Rearranging this, or replacing sec theta by 1 over cos theta, we have 2 over cos theta equals 0.2. This implies that cos theta equals 10. But of course, since cos theta is between minus 1 and 1, cos theta equals 10 has no solutions. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. In this example, we're required to find two values of x for which sec x equals 2 in the interval minus 180 degrees is less than or equal to x is less than or equal to 270 degrees. Now sec x equals 2 implies cos x equals 0.5. We've simply replaced sec x by 1 over cos and rearranged the equation. So let's now take a look at cos x equals 0.5. Here's the graph of cos in the given interval. If we draw a line at y equals 0.5 as shown, we can see one solution, at least, at 60 degrees, as indicated. However, the line does cross the graph at another place as well, namely here at minus 60 degrees. Therefore, there are two solutions. Cos 60 degrees equals 0.5 and cos minus 60 degrees equals 0.5. This brings us to the end of this session. If you have understood its contents, you should be able to solve equations, simplify expressions, and prove simple identities which involve secant, cosecant, and cotangent. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.